about the lack of efficiency in that protocol, that if the channel has the ability to have huge amount of bits, stop and wait will allow me to only send few bits, in which case I have very low utilization of the channel. So stop and wait is a perfect example where the protocol design limits your throughput or your ability to utilize the channel capacity. So we have gone through this motivational example where we have the bandwidth delay product on the medium. It gives you 20,000 bits, and actively you have sent only 1,000 bits as part of the stop and wait because you had to wait until the frame goes all the way to the receiver, and then the acknowledgement comes back, which takes 20 milliseconds. And based on طيب, Bismillah ar-Rahman ar-Rahim. So we started to talk about flow control, flow and error control last time as part of data link control. And we have talked about the error-free channel when there is no possibility of error in the channel, in which case we talked about the simplest algorithm. And we talked about the stop and wait, but without ARQ. Then we have started to talk about the more practical type of channels where there is a possibility of packet loss or corruption, in which case we talked about stop and wait ARQ. And for stop and wait ARQ, I'm allowed to only send one frame at any point of time. So one frame is allowed to be on the channel at any point of time, and I cannot send any other frame until I get an acknowledgement about the frame that I'm sending, in which case we have thought we had a utilization of only 5%. Then we said that if we were to have an imaginary protocol, which we will talk about today, that can send 15 frames without having to wait for acknowledgement, then we can improve the performance quite a bit, because then we have 15,000 bits we can send without having to wait for acknowledgement, in which case we effectively use the channel to send 15,000 bits all at the same time without having to wait for acknowledgement, in which case the utilization of the channel has been pumped up to 75% as opposed to only 5%. This is a huge improvement. This protocol, which we will talk about today, is called the Go-Back-N. So Go-Back-N talks about a protocol that allows me to send n different frames without having to wait for acknowledgement. We send these frames pipelined. That's why we go back in. Sometimes they call it pipeline protocol. So you can send up to n frames, and then if you don't get an acknowledgement, which is unlikely, of course, but we will talk about a scenario that this could be possible. If you send all the n frames without receiving any acknowledgement, only then you can wait, or you have to wait. So if you have a sender and the receiver, so instead of sending only one frame and waiting for acknowledgement, in that case, no, we'll send 1, 2, 3, up to n different frames. Of course, the assumption here is at some point I will receive an acknowledgement, okay? In which case, by receiving the acknowledgement, it allows me to send more frames. So we'll see how the mechanism works now. So one big difference is that, of course, as we said for the stop and wait, I have two states. So if I send a frame, this is frame 0, let's say, okay, and then the acknowledgement is lost, then I have at some point to send the same frame 0 again. So the receiver needs to distinguish whether this frame is actually a new frame or a duplicate frame. So that's why we use only 2 sequence numbers. Okay? Here, I'm allowed to send up to n frames. Okay? So in that case, we will have, of course, more sequence numbers. So we will need more sequence number than just 2. So we will have 0, 1, 2, 3, 4, all the way to n, and then we can recycle. So we will have the sequence number. It's actually it goes all the way from 0 all the way to 2 to the power m minus 1, or in other words, you have 2 to the power m different sequence numbers. And here this means that you have like a register that has a size of m bits. So if you have a register with m bits, then you have number of combinations, of course, 2 to the power m, which goes from 0 all the way to 2 to the power m minus 1, right? So typically the register size goes by the number of bits. So as you have more number of bits, you can double the sequence numbers. So the idea here is that 2 to the power m has to be more than the number of frames that you send, as we will see. So what is the relationship between the two? That's what we need to discuss. Type. So Go-Back-N, of course, because it's allowed to send up to n different frames, we use like an imaginary or a virtual box, which we call it here the sender window. This sender window, of course, as the name suggests, it exists at the sender side, because at the receiver side there is no receiver window in Go-Back-N. So this sender window is just a logical box that goes through the socket buffer. It starts with a parameter called start or SF, or the first sequence number, and it goes to the n sequence number, okay, or the nth frame, the small n, and it is allowed to go all the way to capital N, which in that case it's 14. So so this virtual box divides the socket buffer into 4 different zones or 4 different areas. Okay, so in general, this virtual box exists somewhere in the socket buffer. So the first area here talks about all the frames that these are outside the box on the left side, on the left-hand side of the window. So this area actually contains all the frames that have been sent successfully and have been acknowledged successfully, which means I have done already all these frames. I have sent, received the acknowledgement, so everything is fine. Okay? Inside the window itself, there are 2 zones or 2 categories. The category number 2 inside the box contains some frames that I have sent, but I did not yet receive an acknowledgement for them. Okay, but since I have a window of frames that I can send, I'm not stopping, I'm not waiting. So this is not stop and wait. So I'm continuing to send more and more frames. Okay, so category number 2 contains all the frames that have been sent but not yet acknowledged. The other part of the window, okay, contains the frames that I did not send yet, okay, but I can send. If these frames exist, I can send them right away, because I'm allowed to send up to n capital N frames without having to wait for acknowledgement. So this is category number 3. So inside the window, I have all the frames I can send. Some frames I already sent, but I'm waiting for acknowledgement. The other frames I did not send yet, but I can send if I want. Okay? And of course, the number 4, or category number 4, contains all the frames that I cannot send. I cannot even send because they are outside the window. Okay? So this is the how the sender window divides the socket buffer into 4 different areas or 4 different categories of frames. So another thing we need to pay attention to is that of course in stop and wait, this window is a special case of one. I have only one parameter pointing to one frame, and this frame is the only frame that I can send, which means that SN and SF are combined into one parameter that points to the frame that I sent. I'm waiting for acknowledgement, and I cannot do anything. Here, I have many frames I can send, so I can send all these frames without having to wait for acknowledgement. So in the case of stop and wait, this pointer that points to the frame that I am sending, okay, is only allowed to increment, right? So when I receive the acknowledgement for the frame, I increment, right? So this is how it works. So in stop and wait, I have many frames, okay, and the SN points to a frame that I'm already sending now, okay, and I cannot move to the other thing, I cannot increment SN to the next one until I receive the acknowledgement. If I receive the acknowledgement correctly, then I can increment SN, and SN goes by increment. So in Go-Back-N, there is a very important feature that the window is actually sliding. And in general, I can slide the window more than one location in one shot. This is very important. Okay, so the window, it doesn't necessarily increment, it actually slides. And the window can slide more than one position in one shot. Okay, so how does this happen? Can anyone guess how does this happen? How could this actually ever happen, that the window itself, can slide more than one shot at the same time? ده سؤال صعب شوي. Okay, so imagine I have a sender and I have the receiver. Okay, I sent the first frame. Okay, I don't have to wait. I can send the second frame. I can send the third frame. Okay, and at some point when I receive the acknowledgement, here I can slide. Okay, but there is a chance this slide may happen 3 positions at the same time. This is exactly what happened here. So this shows the window after sliding. Okay, so we can see that here frame number 0 and frame number 1 and frame number 2. Okay, and when I did the slide, I slid 3 positions all at once. So when could this happen? This could happen if, for example, so the receiver, when I sent frame 0, the receiver tried to send acknowledgement, and of course the acknowledgement here will have a sequence number of 1, right, or acknowledgement number of 1, and this acknowledgement was lost. Okay, Does this cause the sender to stop or to wait? No, the sender can send because I have n frames I can send. The receiver received another frame, so it sent acknowledgement number 2. Okay? This acknowledgement was also lost. Does this cause the sender to stop? No, the sender can still continue sending more frames. When the receiver received frame number 3, it can actually, sorry, this is 2, of course. And when the receiver received frame 2, it actually sent acknowledgement with the acknowledgement number 3, and this acknowledgement reaches the sender. Okay, so in that case, the sender will say, oh, okay, so this acknowledgement, as we said before, acknowledgement always indicates that anything before 3 has been received successfully. Okay, so this means that I'm expecting the next frame to be frame number 3. Okay, but frame number 2 and frame number 1 and frame number 0 have been received successfully. So in that case, I can just slide the window 3 positions in one shot. And that's actually a big advantage for Go-Back-N, because Go-Back-N, remember these 2 keywords for Go-Back-N. Acknowledgement is actually cumulative. Okay, acknowledgement is cumulative. Okay, this is very important. Acknowledgement is cumulative. The second thing is that reception is always in order. Because we will talk about a case where we will talk about a case now where the reception is not necessarily in order. Okay, but for Go-Back-N, the reception is always in order. This is very, very important. So if you remember those 2 keywords, okay, you will understand a lot about Go-Back-N. Acknowledgement is always cumulative. So just the fact that I lost these two acknowledgements, okay, it doesn't mean that the sender will stop. And actually, acknowledgement number 3 overrides acknowledgement 2 and acknowledgement 1. Okay, overrides the 2 acknowledgements, which is a very good advantage. So even if the feedback channel is not is erroneous and it keeps losing acknowledgements, this may not affect the performance of Go-Back-N by any chance, which is a very good advantage, right? So not only do we utilize the channel more efficiently using Go-Back-N, even if there are some acknowledgements lost, acknowledgements are in nature cumulative. So receiving one acknowledgement may, in fact, override all the previous ones. This is reflected here by the fact that we can slide the window more than one position in one shot. And that's a very good feature of Go-Back-N. واضح يا شباب? Any questions so far? Is it clear? Okay, so the other thing here we need to notice is that the sequence number, the sender window size, the sender window size has a sender window which is maximum 2 to the power m minus 1. In other words, if you take a look at the at all the sequence numbers, what is m here? What is m? Yes, what is m? Yes. how much is it? يعني what is it? It is the number of bits, yes, but what is the number of bits in this particular example? So I'm talking about a very specific example now, right? So the sequence numbers goes from 0 all the way to 15, obviously. So M is 8, M is 4. Yeah, so M is 4. Yes, so M is 4, right? So the sequence numbers are 2 to the power 4, which is 16, right? So the window size, the window size for the sender, okay, is maximum 15. It cannot be 16. Okay, and I will show you an example visually now, which proves this. So for now, just take this as a fact. Okay, we cannot have a window size equals to the number of the sequence numbers. So the sequence numbers here are 16. So the window size has to be maximum 15. It cannot be 16, and I will tell you why. Okay, so the window is characterized by 3 different parameters now. Of course, SF, which always points to the first frame, okay, which may have been sent already, okay. The SN, which points to a frame that I'm currently sending, okay, and of course the S size, which is the duration of the window, which is the capital N, which is part of the name Go-Back-N. Okay, so these are the 3 parameters. These 3 parameters are very, very important. So whenever we try to send a frame, we have to check, we must check that this frame lies in somewhere in the window. In other words, we have to make sure that SN does not go outside the window. Okay, because if we keep incrementing SN as we send more frames, right? So there is a chance that we increment SN and it goes beyond SF plus the size of the window. So it goes here. So can we have SN here? Of course not. We cannot do that, because if we reach here, this means what? This means that I have already sent N, capital N frames, and I did not receive one single acknowledgement, which is a very unlikely situation, but it could happen, right? So I cannot allow SN to go beyond the window. This is very important, okay? So, so we agree on that. So the sender window is characterized by those 3 variables: the SN, the SF, SN, and the size. Okay, the size of the window. So the sender window can slide more than one slot when a valid acknowledgement arrives. Why? Because acknowledgement is cumulative. This is very important. Okay, acknowledgements for a Go-Back-N are always cumulative. And why is this? Because of the fact that the reception at the receiver side is always in order. We cannot have, if you have, for example, frame 0 and frame 1 is lost, and then frame 2 arrives to the receiver, can the receiver accept this? No. The receiver will not accept frame 2 because frame 1 did not arrive. Okay, so the reception at the receiver is always in order. So the receiver is strict for Go-Back-N. It cannot accept any frame out of order. So that's why the receiver window is actually 1. Why? Because I'm always expecting 1 frame to come, because If I receive frame 2, the expectation is that I'm expecting frame 3. I cannot expect frame 4, right? So I'm always looking, or I'm always pointing at the location for the frame that I'm expecting. And it's always one frame that I'm expecting, which is the one in order, okay? I cannot accept frame 4. I cannot accept frame 5. So in other words, the window for the receiver is 1, okay? So now for stop and wait, the window for the sender is 1 and the window for the receiver is 1. For go back N, the window for the sender is N and the window for the receiver is 1. Okay? واضح كده يا شباب؟ Since I have only one pointer that points to the frame that I'm expecting at the receiver, so again, this pointer goes by increment. It's not, so I do not slide more than, I cannot slide more than one slots at the receiver at the same time. Because the logic is that I received frame 3, so I increment to frame 4. Okay? So I cannot have 5 frames at the same time. I have to receive only one frame at a time, right? So I receive frame 3, I increment to frame 4. I receive frame 4, I increment to frame 5, and so on. So there's always one frame in order that I am expecting. I cannot accept frames out of order. واضح كده يا شباب؟ So far so good? Easy? Difficult? Okay, good. Good. Okay. So the receiver window is abstract window of size 1. حلو? With only one single variable. So because of the fact that on the sender side we have a window of n frames, that's why we need 3 parameters to characterize that, right? On the receiver side, it's very easy. It's only one parameter because we have to always go in order. Okay, so sliding is based on increment. It has to always go based on increment. What is the end result? The end result now is that, okay, so we ended up having the same number of events. So we have the same number of events like stop and wait, yani. So we have again request from above, from the network layer, acknowledgement from below, and the timeout. So it's the same. So as an overview, we have the same number of events at the sender and the same number of events at the receiver. Okay? So ايه الاختلاف هنا؟ الاختلاف is how to handle these events. So each event handler, as we will see now, is different. Okay? One fundamental difference here is to notice that on the channel, this is the main advantage for Go-Back-N. On the channel, we can have up to n, capital N frames at the same time on the channel, which solves fundamentally the issue of channel utilization. Okay, so we have up to n, capital N frames. Okay, so that's because on the sender side we have this window, which is characterized by the parameters we talked about, but on the receiver it's still the same. There's only one pointer pointing to the location that we are expecting in order. Okay, طيب. Talking about code. طيب, let's talk about why. Yeah, so before that, let's talk about, as we said, that the sender window size, okay, is in fact less than or equal to 2 to the power m minus 1, right? So where did this come from? So if we see this, these two examples talk about two scenarios. In the first scenario here, we have here the sender and the receiver, and the window size The window size here, as you can see, is 3, and the sequence numbers are 4. Okay, so this scenario confirms this constraint, right? So according to this constraint, this scenario is correct because the size of the window is 3 and the sequence numbers are 4. Okay, so the window size is less than the sequence numbers by 1. So this should be correct. So let's talk about the extreme example where we have the feedback channel. The channel through which we send the acknowledgement is very erroneous. Erroneous معناه ايه? Every time we send the acknowledgement, it gets lost. Every time we send the acknowledgement, it gets lost. So all the frames, they arrive from the sender to the receiver, and all the acknowledgements, they do not arrive from the receiver to the sender. This gives you the worst case scenario. Okay, in stop and wait, we talked about the same example for one frame, right? And we have reached the worst case where we have to replicate the same frame again, and therefore we came to the conclusion that we need to have 2 sequence numbers, 0 and 1, 0 and 1, 0 and 1. Here, we need to have capital N plus 1 sequence numbers. Okay, why? Because if we assume that all the acknowledgements, they get lost, so what happens is that I send frame 0, acknowledgement is lost. Okay, I don't have to wait. Send frame 1, acknowledgement is lost. Okay, I send frame 2, acknowledgement is lost. Here, the window is only 3, right? So in that case, in this case, after sending frame 2, I have to stop. Okay, until the timeout happens. When the timeout happens, what do I have to do? I don't know which frame did not arrive. So what is the only choice I have? What is the only choice I have here, Shabab? Resend what? Resend what? You resend, yes. So I have to resend all the frames from the beginning of the window because I sent 3 frames and you did not tell me anything. So I don't know which one did not arrive. I don't know. So the only choice I have is to go back from the beginning of the window and send frame 0, frame 1, frame 2. Right? Although, of course, the receiver was receiving everything. So the receiver, in fact, received frame 0. When it received frame 0, it actually increment. Received frame 1, it increment. Received frame 2, it increment. Right? And then the sender timed out, so it started to send frame 0 again. Okay? So does the receiver accept this? No, of course, because it's expecting frame 3 and it received frame 0. So I will discard. Okay? So when I discard, halas, I don't have to do anything. Right? So for me, I discard. So you send me frame 2, oh, I will discard. You send me frame 1, I will discard. I'm expecting frame 3. So here, what happens is that the receiver here will actually send acknowledgement 2, which is the last one that it was or acknowledgement 3, sorry, which indicates that I have received up to frame number 2 correctly. And it keeps sending that. If that acknowledgement gets lost, I cannot do anything. I will have to go back from the beginning, send frame 0, 1, 2, 0, 1, 2, 0, 1, 2, until, inshallah, one of these acknowledgements, acknowledgement 3, will have to arrive to the sender. Once the acknowledgement arrives to the sender will slide 3 positions and it will start sending frame 3. So this is working as designed. That's the best I could do when the feedback channel is erroneous. But it's working as designed. There's nothing wrong with it, right? Let's talk about this scenario where, if we notice here, the window size is equal to the sequence number, because the sequence number here is 0, 1, 2, 3, and the window size is actually 4. Okay, so here I sent frame 0, frame 1, frame 2, and frame 3. Now I'm allowed to send frame 3. Okay, so in that case, the receiver will increment and it will point to frame 0 here, right? معايا so far? So now the receiver will point to frame 0. Okay? When the sender times out here, it has to go to frame 0, this one, okay, and send it. Okay? So what will happen here بقى? What will happen here? What's wrong with that? Yeah, what will the receiver do here? Right. So here remember, this frame 0 and this frame 0, are these equal? They are not equal. خد بالك, these are not equal. Just the fact that they have the same sequence number, it doesn't mean that the content of the frame is the same. This is extremely important. So just the fact that the sequence number recycles, it doesn't have that the frames, they contain the same data. So in fact, this frame and this frame, both are different from each other. So here we have done a big mistake. We have completely damaged the transmission. Why? Because this is frame 0, the one that's part of the window, and now you have caused the receiver to accept it as if it's the one outside the window. So this will damage the whole transmission. Okay? This frame 0 later on will go up to the network layer. So I have delivered this frame as if it's this frame, although they contain different data. So in other words, I have corrupted the network layer completely. Okay? So in order to avoid this situation, we have to make sure that the window size has to be less than the sequence numbers, at least by 1. In other words, this worst case scenario, by the way, if we visualize it, we see that the worst case is when you have logically the receiver window and the sender window, they are next to each other, concatenated. Okay? And because they are concatenated together, the sequence number inside both windows, they need to be different. So you cannot have the two windows concatenated together and you have the two sequence numbers the same, which in that case, it is the case because you have 0, 1, 2, 3, 0. Okay? You can never have this situation. This situation is wrong. That's why the window size at the sender side has to be less than the sequence numbers, at least by 1. Or in other words, and I can generalize this for all the techniques, and you will see that this inequality holds for all the flow and error control techniques. The size of the sender window plus the size of the receiver window, okay, has to be less than or equal to the sequence number. Okay? So this holds for all the techniques. So in other words, this one here is actually the size of the receiver window, because the size of the receiver window is 1, right? If we apply this to the stop and wait, what is the size of the sender window? 1, صح? What is the size of the receiver window? 1. So we need to have 2 sequence numbers. That's what we said. For stop and wait, we need 0, 1, 0, 1, 0, 1. صح? For go back N, it's the size of the sender window, which is capital N, right? Plus the size of the receiver window, which is 1. So we need N plus 1, or in other words, 2 to the power M needs to be N, capital N plus 1. And as you will see when we talk about selective repeat, still this inequality holds. ماشي كده يا شباب؟ Any question so far? Is this scenario okay? Anything is not clear here? So go back N, the size of the receiver window is always 1, and the size of the sender window has to be 2 to the power M minus 1. Okay, must be less than 2 to the power M, but by at least 1. ماشي? Type. What is the pseudocode? The pseudocode for the sender, we will start to talk about the differences. بحيث ان احنا we need to relate what we are discussing now with the stop and wait. So we need to spot the differences. Where are the differences? So these are the 3 variables that we talked about that characterize the window. So we have SF and SN, which both, of course, they start from 0, and you have the window size, which is 2 to the power M minus 1. So in stop and wait, if you remember, we had here can send flag, right? So we had the can send flag. So because we had only 1 frame, either we send it or we have to wait. So there's no here, but now we have more than 2 states, so we cannot use a flag here. So every time we send, we have to make sure that SN, as I said, SN, and this is SF, and this is a SW. Okay, so we have to make sure that when we try to send SN does not get outside the window. So SN does not get somewhere here. Okay, because every time we send, we have to increment SN. So we have to make sure that SN minus SF is greater than or equal to SW. If that's the case, then I cannot send. So I got a request to send, and unfortunately the frame is outside the window. Can I send it? No, of course I have to wait. Right? So in that case, I have to wait. So I don't have to do anything, so I go to sleep. Other than this, you see that the same sequence of stop and wait, okay? Except there's one also good advantage for stop and wait is that, of course, I have to start the timer. So here we have if the timer not running, then start it. And this is very key because this indicates that I only need 1 timer for go back in, only 1 timer. Okay. So here I do not have to specify anything. It's 1 timer for the entire protocol. Even either it started or it stopped. Okay, why? Because again, the delivery of the frames at the receiver side has to always happen in order. So I only need 1 timer per the entire window. Okay, I only need 1 timer only. For the next one, as we will see, we need more than 1. But here we have only 1 timer for the entire window. So that's why if I send multiple times, I only need to start it at the beginning, okay? And then, خلاص, I keep it running. When I receive an acknowledgement, as we will see, we have to do something about the timer, okay? But for now, we just need to start the timer only once. So that typically happens when SN is at the beginning here, SM, SN, and SF are both equal. Okay, so in that case, I'm starting to transmit frames at the beginning of the window. So typically, when I start at the beginning of the window, I start the timer. But when I start to send more frames, خلاص, the timer is already running, and I don't have to do anything about it. So I just need to keep it running. Okay, so that's a very important rule for the case of Go-Back-N, is that the timer is only one timer for the entire window. طيب, other than this, you will see that the logic is the same. And طبعا هنا you have to pay attention to here that this increment Sn gets incremented every time we send a frame. But this is actually this is modulo 2 to the power m. This is modulo 2 to the power m, which of course, for the case of stop and wait, m was actually 1, so we only need 2 sequence numbers. Here we have up 2 to the power m, and m here is general, it can be any number of bits. Okay, طيب, as we said, because of the fact that packet can get lost, we had to store the frame. Here's to keep copy. We have done this for the stop and wait, صح? So first, so there's a slight change for the case of Go-Back-N when it comes to handling the event for the request to send. The main thing here is that we need to do 2 extra steps compared to stop and wait. We need to make sure that when we send SN does not go outside the window. And the second thing is that if we are at the beginning of the window and the timer is not started, we have to start it. And it's only one timer per the entire window. Okay, so I don't have to every time start the timer because it starts only once. Type. For the case of arrival notification, remember when we receive anything from the physical layer, we have to make sure it's not corrupted. Okay, because physical layer means it receives something from the transmission medium, and transmission medium is in nature imperfect, and it could be noise, there could be packet loss, there could be things like that. So we have to make sure that it's not corrupted. So if it's corrupted, sleep, I don't have to do anything. If the acknowledgement is corrupted, I have nothing to do with it, so I will just ignore it and sleep. طيب, what is the other condition? Again, if the acknowledgement is coming for something outside the window, I cannot do anything about it. So only when the acknowledgement is coming for something inside the window that I can process it. Okay, so I have to make sure that the acknowledgement is also within for acknowledging a frame within the window. Because only then I'm allowed to slide. So I need to slide. And as we have talked about before, sliding can happen more than one position at the same time. So if let's say SF is here, so this is let's say this is frame 1, frame 2, frame 3, frame 4, and now this is SN. Okay. The acknowledgement number is actually 3. Okay. So how many positions I need to slide now? So this is SF. When I slide, I change SF, of course, right? So by changing SF, I essentially slide the window. By changing SN, I account for frame transmission, right? So how many positions do I need to slide in this case? Ahsin. Yeah, which means that SF will go to here, right? So so I will have to increment and then increment. Okay, that's why here this is less than. Okay, once it's equal, I stop, right? And here there was a typo, by the way, in the book, that there was an equal here, and I removed it because it shouldn't be equal. So every time I have SF less than the acknowledgement number, I increment, right? So I increment once and twice, and then once it becomes 3, then I go outside the while loop and I stop. Okay? Type. When I slide, I can actually I can avoid this while loop and say, okay, so SF على طول equals to the acknowledgement number. صح? I can do this in one step. I don't have to do the while. The only reason I did the while is to purge. Because remember, so because of the fact that we have to keep a copy, here I have to purge whatever I have a copy for, I can purge. So that's why I need the while loop. Otherwise, I can just do the sliding all in one statement, just SF equals to acknowledgement number. That's it. Very easy. Okay. But I had to do this while loop in order to purge. That's all. Then when I receive the acknowledgement, I stop the timer. Why? Why? Because the timer is one per window, right? So because of the fact that I'm receiving acknowledgements, this means that the receiver is actually receiving some frames, right? So I will have to stop the timer and then restart it when I transmit the next frame. Otherwise, if I keep it running here, it will expire even though I'm receiving acknowledgements. Or the idea of the timer is just to count the duration of time that I'm not receiving acknowledgement. Here I am receiving acknowledgement, so I will stop the timer and then I will restart it again when I send the next frame. So this will allow the timer to restart fresh and give me the ability to stay for a long time to account for not receiving the acknowledgement. This is بقى the main disadvantage for Go-Back-N. This is the main disadvantage. When the timer expires, okay, I don't have any choice. I have to go back from the beginning of the window. Okay, I have to go back all the way from the beginning, and I have to resend all the frames since the beginning of the window. So I go back to SF, okay, and I will start to send every frame again, but without sliding, of course. Okay, so once the timer times out or expires, I have to go back from the beginning of the window and resend everything. And again, there is a typo in the book here because it uses the temp variable, and here it uses SF. And this is wrong, of course. I actually fixed that. Because if you use SF, essentially what you do is that when you increment SF, this means you are sliding. Of course, here I should not slide. When I time out, I send the frames, but I do not slide. معايا يا شباب? So here I have to send the frames, but I should never slide. The receiver بقى looks exactly the same. The receiver is exactly the same. There's no changes whatsoever, except that here this is modulo 2 to the power n. That's it. This is the main difference for the case of Go-Back-N when it comes to the receiver. Why? Because the receiver has, again, the same window size, and it always expects everything in order. Okay? So the only thing here is that we have to account for the fact that the sequence number is is actually a 2 to the power m. Okay, which could be more than just 2 sequence numbers. It can be up to 2 to the power n. Okay, no other changes. Okay, and of course, when I deliver the frame to the network layer, okay, this means that, of course, I receive the frames in order and I deliver them to the network layer in order. Any questions so far, Shabab? So this here talks about the fact that for Go-Back-N, we have very clear characteristics. We have cumulative acknowledgements. We have in-order reception at the receiver. We have one timer for the entire protocol. But we have one disadvantage. The disadvantage here is that whenever this timer expires, I have to resend everything in the window. Okay? But as I have shown you in 2 minutes ago, that sometimes the receiver receives all these frames, it's just the acknowledgement was lost. So when the timer expires, I have to resend all the frames, which is a waste. It would be nice to recognize which frame got lost, and resend that frame only. Okay? So if I have a sender and I have a receiver, if I send frame 0 and then send frame 1 is lost, send frame 2, okay? The problem is that this frame 2 will not be accepted by the receiver, okay? Will not be accepted because it's not in order. But I can send frame 3, I can send frame 4, and so on. If the timer expires, I have to go back and resend frame 1, frame 2, frame 3, frame 4, and so on. This is the problem. It would be nice if I only need to send frame 1, which is the one that was lost. But frame 2 and frame 3 and frame 4 should be accepted by the receiver. In order for me to do that, I have to change the mechanism of the receiver significantly. Okay? I have to change significantly the mechanism at the receiver side. So this is the timing diagram for the case of Go-Back-N. And here we notice that what's M here? M here is 3. Why? Because we have the sequence number going from 0 all the way to 7, which is 8 sequence numbers. So M here is 3. And of course, we have the window size. The window size is 7. So 7 is less than 8. So here, in terms of design, this fulfills the condition. So in that case, the protocol should work just fine. So here, if I send frame 0, I receive the acknowledgement before I receive any request to send frame 1. So this is the happy pass, and this works like stop and wait. But it happens by chance because the network layer did not give me frame 1 after frame 0. So I waited for the acknowledgement, and the acknowledgement arrived. So khalas, that's fine. I will have to slide the window 1 position, and that's it. Then I send frame 2, I send frame 1, sorry, and then I send frame 2. But the acknowledgement for frame 2 is lost. This is a good advantage for Go-Back-N. Because of the fact that the window size is 7, I can send frame 3, I can send frame 4, I can send frame 5, I can send frame 7, I can continue sending. Acknowledgement 3 has arrived, okay? So it did not affect the performance of the protocol in any way. Why? Because acknowledgement 3 supersedes acknowledgement 2, even though acknowledgement 2 was lost, but it's fine. Why? Because acknowledgements in Go-Back-N are cumulative. Okay? So acknowledgement 3 supersedes acknowledgement 2. Acknowledgement 4, okay, overrides any acknowledgement before it. So that's good. That's a good advantage. So now we look at the time diagram where again we did the transmission for frame 0, and then acknowledgement 1 arrived, and now the frame got lost. This is the main disadvantage for Go-Back-N. Frame 1 was lost. I do not have to wait, so I send frame 2, frame 3, and I can continue like this, send frame 4, frame 5. Okay, but here is when the timer expires. When the timer expires, I have to go back from the beginning of the window and send frame 1 again, send frame 2, send frame 3 again. Although frame 2 and frame 3, they already arrived to the receiver, but the receiver had to the receiver here had to discard anything starting from frame 2. Okay, so starting from frame 2, the receiver discarded all these frames. Why? Because they are arriving at the receiver out of order. I'm expecting frame 1 and I receive frame 2, discard. I'm expecting frame 1, I receive frame 3, discard. So the reception at the receiver is always in order when it comes to Go-Back-N. So this is the main advantage this is the main disadvantage for Go-Back-N, that all these frames have to be resent even though frame 1 is the only one that's lost. Whenever what? Yes. Yes. Here, you mean here? So below that, yeah, just below here. Right. Yes, that's a very good observation. That's a very good observation, right? So here I will stop the timer, but actually once I try to send any frame, I will restart. Okay, so I will restart anyway, and restart. This means that after some time it will time out. But you're right, here I have to stop the timer because I received acknowledgement. Whenever I receive acknowledgement, I have to stop the timer. It will still time out. It will still time out, but this is more correct. What you are saying is correct. So I should, following this logic, I should make sure to stop the timer and then restart it, which is not shown here. It's not shown exactly here, but you're right. Not necessarily. Not necessarily. Not necessarily. So I will start the timer. I will start the timer somewhere here, and it will time out. Whenever it times out. But the issue, actually calculating the time out is a big issue, by the way. I didn't. What would be a reasonable timeout? That's an issue. Because the timeout, if it's too short, okay, this means that it's less than the round trip time of the acknowledgement. So before the acknowledgement comes, before the acknowledgement for one frame comes, I will time out. That's a very premature, right? If I make it very, very long, this means that I will send all the frames, okay, and then it doesn't actually time out. So if there's one frame lost, I will have to wait for a few milliseconds until the timer times out, which means I will not react to the packet loss fast enough, which means I will not utilize the channel efficiently because I will have to retransmit the entire window. So actually calculating the timeout is a big trade-off. Okay. Okay. So for the case of Go-Back-N, so yeah, so we talked about this. So stop and wait is a special case of Go-Back-N when the sender size is when the sender window size is 1. So we know that. So now, in order for us to fix the problem of of Go-Back-N when it comes to resending all the entire window, we have, as I said, to change the mechanism of the receiver altogether. So we have to allow the receiver, this is by a selective repeat. Okay, so for the selective repeat, the sender is the same and it has a window. The difference here is that at the receiver side, we need to have also another window similar to the sender. This is the sender window, but at the receiver side, we need to have a similar window like the sender side. So we have a sender window of size capital N, and we have a receiver window at the receiver of size N برضو, capital N برضو. Okay, so we need to have two windows at the sender and at the receiver. So we'll start next time by talking about the details for selective repeat, because it's a bit complicated compared to Daniel, did you have a question? Sorry, I did not notice you were raising your hand.